Hello my dear students, this is Akash HD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the questions from the 12th part 2. Okay, part 2 means from which chapter to which chapter? From the ray optics to the semiconductors. Okay students, so let's start the video and let's learn all this NEET 2025 questions. So see here, a microscope has an objective of focal length 2 cm, eyepiece of focal length 4 cm and tube length of 40 cm. If the distance of distinct vision of eye is 25 cm, the magnification in the microscope is how much here? Okay, so here they are talking about the compound microscope. First, let's note down the data here. Okay, so objective means f0, it is given here 2 cm. You can see very well 2 cm. Eyepiece, how much is given here? Eyepiece 4 cm, is it? After that, length how much is given here? You can see very well 40 cm. But the question arises, this length is for maximum magnification or minimum magnification. Okay, so remember that here if nothing is mentioned, this is always for the minimum magnification, and this is called the normal adjustment. That means when the final image will form at infinity from eyepiece. I think so you know very well, in a compound microscope two lenses are there, one is the objective and one is the eyepiece here. Okay, so anyhow remember that here the magnification formula for the compound microscope is given by this is the formula V0 by U0 D by UE. Okay, I am writing just to magnitude, otherwise minus sign will come. Now from here two formulas used to come here. The first formula, when the magnification is the maximum and the final image will form at capital D distance. Okay, so in this situation this formula becomes here V0 by U0, and here it will become here 1 plus D by FV. Okay, and second situation, when the final image will form at infinite. Okay, and I will be relaxed. In this situation what will be this here? The formula is V0 by U0 into D by FV here. Okay, this magnification maximum, this is minimum. And here remember that here one approximation we have to use depending upon the situation. Length and all is given. Okay, so the approximation, what is this? When the distance of the object is very close to the objective, or we can tell here this U0 is approximately f0. No? The object is at a distance of how much? f0. That means the focal length of the objective. So in this situation what happens that here this V0 will approximately become here L. Okay, so when I will write here the formula, it will become here mod m infinity is equal to V0 will become here L by f0 into D by FV. Now this is the approximate formula, please remember that here. Now let's put the value here. L value how much is given here? 40. No? 40 by FV value is 4. L by f0 how much here? 2, is it, into D. D is the distinct vision of eye, 25 cm, is it, by FV how much is given here? FV is given here 4. Okay, so when you will simplify this, see 4 10 ja 40, 2 5 ja 10, 5 into 25 how much is coming here? 125 here. So which option is matching here? The correct option is here option B. Compound microscope question is there, little bit approximation. Is it? Great. Next one we'll see here ray optics question is this. The question is what's here? In a certain camera, a combination of 4 similar thin convex lenses are arranged axially in contact. Then the power of the combination and the total magnification in comparison to the power P and magnification M for each lens will be respectively how much is there. Okay, so camera is there. So in a camera remember that here this equivalent power for the lenses, mirror, anything and all, P1 plus P2 plus P3 plus P4, and each of them is having how much power? Each of them is having power P. Okay, so we can write here P plus P plus P plus P. What will become here? It will become here 4P. Is it? Now after that, next one if we talk about here the magnification. So magnification means we will always multiply. Okay, so what this will become here? Just multiply all of them here. m into m into m into m 4 times, that means it will become here m power 4. So this is the equivalent power, this is the equivalent magnification. Which option is coming here? You can see very well, 4p and m to the power 4. Correct option is here option C. Okay, so we have solved 2 questions from the ray optics. Now the next question from the wave optics. Let's see here. An unpolarized light beam traveling in air is incident on a medium of refractive index 1.73 at Brewster's angle. Then here some options are there, like reflected light is completely polarized, or reflected light is partially polarized, or both are perfectly polarized, or transmitted light is completely polarized. Okay, so this question is somewhat informative. Remember that here, if we talk about here, let's take for example, this is air, no, and this is a medium. No, air means, let's take here mu1 is 1, or we can write here mu rarer, and here mu denser. How much is given here? 1.73. Directly Brewster angle formula is there, but remember that here, little bit basic. When the ray will incident from rarer to denser medium, then what will happen that here, when this angle is the Brewster angle, then what will be there here? Some light will be reflected. This is the reflected. Okay, and some part will be what? Refracted, not towards the normal here. This is called the refracted. So remember that here, when the light will incident at Brewster angle, this reflected light will be completely polarized. What is this? Completely polarized. Completely polarized. Refracted light partially. Okay, partially polarized here. Okay, and this angle between these two will be always 90 degree. Make sure that this angle will be always how much here? 90 degree here. So in this situation, remember the formula. This refractive index, now refractive index, that means denser with respect to the other, is always given by how much here? 10 IP. Okay, so this IP will come here. Derivation not required, but as of now 10 inverse. And the mu value how much is given here? 1.73 means root 3. Okay, so hence IP will be what here? This IP will be 60 degree here. Now this is called the Brewster angle here, IP equal to 60 degree. Kindly see very well. Okay, and if you wish, here also you can write here, if this angle IP, this angle will be also IP here. This is 90 degree, then this angle, if you required, you can calculate very easily. Okay, so which option is correct here? You can see very well where is the 60 degree is given here. Here 60 degrees there here. Okay, and let's see here. Reflected light is partially polarized. No, reflected light is completely polarized. That is not possible. Now let's see here. Next option. So here you can see, let's take this one here, option A, reflected light is completely polarized and angle of reflection is close to 60 degree. Angle of reflection is close to 60 degree. Where is the angle of reflection? See here, please, student. If this angle is 60 degree, from the law of reflection, we can tell this angle is also 60 degree because I is approximately R. Not approximately R, actually, I is always R. This one here. This I am telling that here, this one I am talking about here. For this I am telling here R. Okay, so which option is correct here? The correct option is here option A. Now angle of reflection is not close to 60, actually 60 degree here. Okay, TIR is happening. Okay, so from that perspective we can tell, no, because for TIR what is the condition? I should be greater than the critical angle. From that perspective they have told close to. Okay, next one, let's see here again, ray optics question is there. See, the intensity of transmitted light when a polarized sheet placed between two crossed polarization at 22.5 degree from the polarization axis of one of the polarized, okay, is, and here they have given what is the I naught. I naught is the intensity of light after passing through the first polarized is there. Okay, so what they are telling that here, the students here they are putting here a sheet is there, that is placed between two crossed one here. Crossed means how much angle? The angle is how much here? The angle is 90 degree here. Okay, so what will happen that here? Remember that here, see this one here, no, this one here, this is the first, no, and we can tell here, let's take here like this here. For example, I am telling that here. Okay, this is called the transmission axis here. No, like this is the transmission axis here. Okay, let's take axis 1, axis 2. Crossed means they are making how much angle? 90 degree. Okay, so in this what is happening that here? This is first one, this is second one, and in middle we have put one more here. Okay, in middle they have put one more here. Okay, so this is, let's take here axis 3. So A1 and A3 is making how much angle? 22.5 degree. So here we have to use what? Law of Malus. So first thing, if we talk for 1 and 3, what we talk? If we talk for 1 and 3, this 1 and this 3. So what we can write here? Remember that here in this situation, this I3 will come here. Here how much is going to incident here? Polarized light I0. So I3 equal to, we can write here I0 cos square. How much angle it is given here? 22.5 degree here. Now angle between A1 and A2 axis, how much here? 22.5 degree. Now again for 3 and 2. Okay. Now this is I0. I0 is coming is here now, and what is happening that here from here it came here. How much here students? I3. No, I3 is coming here, is it? So see one minute. I3 is here. No, this is the I3. Now I0 entered. How much we got? I3. Is it? Now I3 is going to enter here, and here what we have to see? We have to see angle between A2 and A3. Okay. So remember that here in this situation, if I write here the final, no, final we can write here I final. So what will come here? See here this first I3 and again angle I3 into cos square. You know very well students here, see here, this is one axis, this is one axis, no? And this is one axis. So if this angle is 22.5 degree, what about this angle? This angle is 67.5 degree. Again I am telling that here, okay? Make sure that here, this is A1, this is A2, this is here, this axis is A3, okay? So A1 and A3, 22.5, so A3 and A2 how much is? 67.5 degree, is it? So what will become that here? It will become here cos square 67.5 degree, is it? So now after that we can write here I3 value, we can write here, see, I0 cos square 22.5 degree and cos square 67.5. You can use the formula cos 90 minus theta sin theta. Okay, so you can write here like this here, cos square 90 minus 67.5. So it will become here, see, I0 cos square 22.5 degree dot sin square 22.5 degree here. Okay. Now after that, what will happen that here students? Here we have got it now. So just let me go ahead. Is it here? Is this there now? So see here I will write here. So students, here what we can write here? Just let me see here. So this I final, now I final will become here what here? I0 into sin 22.5 into cos 22.5 whole square here. Okay, and remember that here one more thing we can use here. You know very well, sin 2a means 2 sin a cos a, is it? So we can write here, see here students, sin a into cos a means what we can write here? Sin 2a by 2, is it? And this 2 we can't cancel. So here square means here also square, is it? So what we can write here, see, I0, no, this I final we are writing now, I final, I0, this will become here what here? Sin 2a. So if this angle is a, if this angle is sin 2a means 2 into 22.5 here, sin 45 by 2 square. Okay, so it will become here I0 by 4 and 1 by root 2 square. So when you will simplify this, what will come here? I0 by 8. Is it? Can you see very well how we have done this? Is it? So this is based upon the topic polarization. Okay, great. See here. Now students, next one we'll see here. Before going to the next one here, take the options also. Which option is correct here? The correct option is here. Option C is the answer. Okay, correct option is what here? Option C is the answer. Can you see here? Is it? We have just seen the angle between the transmission axis and all. Now, next one, let's see. The question came in a dual nature of radiation and matter. So see here. If photon and electron have the same energy E, the ratio of their de-Broglie wavelength is how much here? Okay. So here we have to remember that one thing here. Photon travels with the speed of light. Okay. So here we'll use the formula E equal to h nu or E equal to hc by lambda. Photon travels with the speed of light. Okay. So remember that here this lambda photon E equal to hc by lambda. So from there we can write here lambda photon means hc by E. Okay. Next one, if we talk about here lambda electron, here we have to use here the de-Broglie hypothesis formula, h by root 2 mk. K is the energy, but here they are telling E means we'll write here h by root 2 me. This is the lambda photon, this is the lambda electron, is it? So now students, when we'll take here the ratio, see lambda photon by lambda electron. De-Broglie hypothesis means the particle will behave as a wave. Okay. So lambda photon, what is coming here? Let me write here hc by E into lambda electron, what is coming here? See here h, and here it will come here root 2me, is it? So students, just cancel out. What other things can be cancelled? So see here, this h and this h cancelled, so it will come here c into root 2m, root e by e, that means 1 by root e. So it will come here like this here, see, c into root 2m by e. Now c into root 2m by e. Which option is correct here? The correct option is here, option C is the answer here. Is it, students? So this question, see, very easily we have done here. Next one, let's see here. This is from the chapter dual nature of radiation and matter. So many questions came. So see here, which of the following options represent the variation of photoelectric current with the property of light shown on the x-axis? So this graph and all is there. So here this question is the informative. Remember that here photoelectric current depends upon the intensity of light but independent of the frequency of the light. But remember that here the frequency of incident light should be more than the threshold frequency, or wavelength of the incident light should be less than the threshold frequency. So what I told you, photoelectric current depends upon the intensity. This is photoelectric current, PEC. This I is the intensity of light. The here A is there, but here options are there. A only, A and C, A and D, B and D. So correct option is what here? Option 1. Others and all options are wrong only here. Is it? Great. Now students, next one, let's see here. Next one, see here. Atoms question, see. A particle of mass m is moving around the origin with a constant force F pulling towards the origin. If Bohr model is used to describe its motion, the radius of the nth orbit and the particle's speed v in the orbit depends upon here. Okay. So remember that here, whenever the circular motion is there, now so circular motion you know very well here. If any object is moving in a circular path, we need one centripetal force. Okay. So this is the centripetal force, one constant force is there, and radius how much here? The radius is r here. Okay. So what we can write here, students, from here we can write here. Remember that here this mv square by r is equal to F, correct? Because this force will act as a centripetal force towards the center, is it? So now from here what we can write here, students, can you see here, force is constant, m is constant, so I can write here, see, v square equal to r F by m. F and m is constant, that means v is directly proportional to r to the power half. This we got it here, is it? Now after that here, if we'll go for the next one, see here, angular momentum, Bohr's second postulate. What Bohr's second postulate tell that here, see, m in mvr is equal to nh by 2 pi r base, is it? Kindly put the values now. M, and here what is this? V means r power half. No, m, V means r power half, proportional into r is directly proportional to n. Other all things and all is the constant, is it? So we can write here even mass is also constant. So r to the power 3 by 2 directly proportional to n, is it? That means r is here directly proportional to n to the power 2 by 3. Both the sides you can take here 2 by 3, then you can get here, is it? And after that, when we'll go for the speed, what is this? R to the power half. So r means here n to the power 2 by 3, and here half, this half and this half cancel. So what will come here? This v is directly proportional to r to the power 1 by 3. So n to the power, not r, n actually here, okay, n is this, na, n. So see here, n to the power 2 by 3 and n to the power 1 by 3. The correct option is here, option C. Okay, we have used the second postulates of the Bohr model here. Okay, great. Now let's see here, students, this question. Atoms question again, see. De-Broglie wavelength of an electron orbiting in the n equal to 2 state of hydrogen atom is close to. Okay, so we have to calculate here the wavelength, and the Bohr radius is given 0.052 nanometer, because you used to see R1 equal to 0.53 angstrom. Na? Here they have given approximately. So remember that here we have to use the de-Broglie hypothesis in a Bohr model. And what is this here, students, here? 2 pi Rn is equal to n lambda, n. Okay. And n value how much is given here? The n value is given here, students, 2, is it? So see here, 2 pi into R2 is equal to n is 2, and we are getting here lambda 2, is it? Now after that, this 2 and this 2 cancelled, that means lambda 2 is equal to pi into R2, is it? After that, one more thing here, see, you know the formula Rn equal to n square by z into R1. But for which orbit we have to use? Second orbit. Nothing is given, that means hydrogen Z equal to 1, so we can write here 2 square into R1, or we can write here R2 how much here? 4R1. R2 how much here? 4R1. Okay, so this value I will put here, this value I will put here. Then what will happen at here, students? Here pi means 3.14, R2 means 4, R1 how much is given here? See, 0.052. How much here? 0.052 nanometer here. Okay, so this much calculation is this. I will just do little bit approximate. So 3 into 4 into 0.05, is it? So approximately what will come here, students? Here 3 into 3 into 4, 12, 12 into 0.05, approximately it will come here 0.6 nanometer. Now, but I have done the approximation, so if you check here 0.6 here, where you can see very well the correct option is here, option B is there, 0.67 nanometer. We have to just use the de-Broglie hypothesis, that's it. Now students, let's see here this question. Now semiconductors question is there. Now, so see here a full wave rectifier circuit with diodes. Diodes, what is given here? D1 and D2. What is given here, students? D1 and D2 is shown in the figure. If input supply voltage is this one, then at t equal to 15 millisecond, what will happen? Okay, so remember that here what will happen, that here, see, this V in is given here. Let me write here 220 sine 100 pi t. Just put the value of t, what is given? 15 millisecond, that means 15 by 1000, is it? That means here what will happen, that here in this situation, can you see here, this 0 cancel, this 0 cancel, that means it will become here 220 sine and 15 by 10, that means 5 3 is 15, 5 2 is 10, so 3 pi by 2, is it? You know very well the sine 3 pi by 2 value how much here? Minus 1, minus 1. How can you see here? This is the sine graph, is this like this here, no? See, this is the 0, pi by 2, this is pi, and here how much here? 3 pi by 2. Now, and this value used to be how much here? See here, this side plus 1 and this side here minus 1. Okay, so it will become here, see, 220 and this one minus 1. What is coming here? Minus 220 volt. But what is the meaning of the minus 220 volt? Remember that here, minus 220 volt means what will be this here? This is minus, this is plus. Okay, this minus, this plus. Okay, and see very well. Okay, and this plus, this minus, that will be there. No? Because minus 220 volt here, this minus, this plus, minus plus, minus plus. No? I think so. Little bit basics of full wave rectifier is needed. Okay, so D1 is which bias? The D1 is the reverse bias. How can we tell D1 is the reverse bias? If in case in any diode, P side is connected to negative, N side is connected to positive, that is reverse bias here. Okay, and if in case what is this? This is the diode, P side is connected to positive and N side is connected to negative, this is forward bias here. Okay, so reverse bias is the situation for D1 and forward bias is the situation for the D2. Which option is correct here? The correct option is here, option B is the answer here. Is it? Great. Next one, students, logic gate questions are there. Let's go through the question. What is the questions here? The output Y of the given logic implementation is similar to the output of which gate here? Okay, so kindly see here, this is A, this is B. Which gate? NOR gate. That means OR and NOT. So it will become here OR means, and then put the bar here. It will become here NOR gate, A plus B bar. Here, this is which one? NAND. That means AND plus NOT. First AND, AB, then bar here, AB bar here. Okay, so this is which gate? NOR gate. This is which gate here, students? NAND gate. Okay, and this is which gate? AND gate. AND gate. Okay, so what will happen that here? Let's take for example, if I take here, this is M, this is N, so this Y will become here Mn, is it? So students, we can write here, see here, this Y equal to, even you can do by taking 0, 1, 0, 1, 1, 0, all these conditions we can do, but here I am doing here the Boolean algebra here. So see Y equal to Mn. Now, M how much is given here? See here, students, here A plus B bar, okay, dot, and after that what is given here? See the students, here AB bar. Is it? If you wish, you can put here in a bracket also. Okay, and after that, De Morgan's theorem is there. I think so. You know very well here. If in case A plus B bar, it will become here A bar dot B bar. Okay, and if in case it is given AB bar, it will become here A bar plus B bar. Is it? That I am going to use here. Okay, students. So what will become here? Let me see here. A plus B bar. Na? It will become here. See here. A bar dot B bar. Okay. dot. Here what will become here? See the students here, a bar plus b bar. Okay, then just like a basic mathematics, first you send a bar multiply here. So what will become here? See here, a bar dot a bar b bar. Okay, plus again you multiply, see a bar b bar b bar here. Now first a bar multiplication, then b bar multiplication, simple mathematics. So a bar dot a bar only. Okay, this one here. So a bar b bar plus here also b bar only. So a bar b bar here. Again simplify this students here, a bar b bar plus a bar b bar. Is it? Now take here the a bar b bar common. So 1 plus 1. 1 plus 1, not a 2. 1 plus 1 is 1. Okay. So it will become here what? It will become here a bar b bar. Okay. And when you simplify this again, a plus b bar. A plus b bar is what? Nor. Where is the nor here? Option D. Can you see? I have just used here the Boolean algebra here. Okay. You can solve by 101 by taking also. Okay, students. So I hope so. This video of the second part of the 12th, you have understood very well. Keep studying. Keep growing.